Hello and welcome to the lecture on debugging with GDB. First, let's discuss what a debugger is. A debugger is a tool that allows us to run the program against a target program that is executed under controlled conditions. This allows a programmer to track what the operations a program is performing. So in order to allow this ability to have a debugger attach a process, you have to compile your program with particular symbols, often referred to as debug symbols. Now, the debugger that we're going to be using during this course is called GDB. GDB stands for GNU Debugger. It's a portable debugger, which we'll be using to attach our C programs to. So when executing a GDB on the command line interface, we just enter in simply GDB, as it can be seen in this screenshot. And this actually enters us into a interactive shell, different from our bash or what we're used to in Linux. And you can see here below, it says GDB in parentheses. So now let's go ahead and go through an example of debugging a program. We're going to go ahead and write this program. So go ahead and open up your editor and just write what you see on the screen. You don't really need to understand exactly what's going on, but if you just read through the code, you may intuitively understand what is happening. Now, what we're going to be doing is we're going to be compiling this. We're going to be compiling it with our debug symbols. So just as we learned before how to compile our programs, we are going to compile our program now with the G flag. And this G flag will produce the debug symbols for our GDB program to attach to our process. Now you can see here in the screenshot below that I compile the main.c program in the prior slide with the -d flag, and it produces the same a.out file that we're used to seeing. So if we go ahead and launch GDB, we'll see that we're currently inside of it, as pointed out in this arrow here. Our first command that we set in GDB is we tell it to load a particular binary file. So we say file and then we type the file name. You can see it gives us some feedback saying reading symbols from this file, and the symbols that it is referring to is the debug symbols. That is that dash flag that we pass into GCC. So we're going to set something called a breakpoint. Now a breakpoint is basically saying halt the program at a particular line. And we'll get into that in just a second. So we set a breakpoint and then we tell GDB to run our program. And you can see here that it reaches a breakpoint and then it tells us our first line int x equals 10. So we run the program and it halts execution at a particular line, which appears to be line 5. Now, a breakpoint, like I said previously, is a particular point in the program that halts execution. Now, since we are controlling or orchestrating the actual execution of our program, we have the ability to manipulate variables on the fly and step in and over code. And the term stepping really just means executing a particular line of code or going into a function. There's a lot of different things that you can do. So let's go ahead and try to get ourselves a little bit more familiar with GDB. All right, let's go ahead and use some of our newfound knowledge for GDB and write a simple program that is going to be attached to our debugger. So let's go ahead and launch our Visual Studio instance. It should automatically connect if we've already set it up to our Windows Subsystem for Linux instance. And let's go ahead and cd into our normal directory c-dev. Now that we're in here, we should have a clean directory, and if not, you can reuse the files that you've had before. We're basically just sticking with one file for these tutorials, but however you like to maintain your file system, that's up to you. So clear the screen. We're going to go ahead and touch main.c and make a new file. We see it pop up over there. Let's go ahead and edit this. We can type in code and main.c, and I'm using the autocomplete feature quite a bit here. So just in case you forgot what's going on here, I can type in a program name, code, COD, and then hit tab, or I can hit it multiple times, but you see a whole mess of programs. So it's better to just type code, and then if I want to autocomplete the program name, I can type main and it will just autocomplete for me, or MA, and it will autocomplete because it will check the current directory. All right, so it opened up our file. We have it up here. Let's go ahead and just write a very basic program. So I'm going to write a program that is just going to display 2 integer numbers on our terminal screen. So we'll go ahead and declare 2 variables, and x is equal to, let's say, 5, and y is equal to 10. And we are going to print both of these. So we'll say this. Same thing for y. And that looks good. So we're going to go ahead and print out our values for x and y with our respective variable names to the left. And let's go and expand our console. We have this open. Save that file just in case. Come back down here, clear our screen. And when we compile this time, we're going to pass in our -g flag to create our debug symbols. So we'll write gcc -g main.c, enter. And you can see that we've created a.out. We can also list, and there's a.out. Let's go ahead and just run it, and we can see exactly what happened. It prints out our values for x and y. So now let's go ahead and launch a GDB instance. We can go ahead and expand this, clear the screen by typing Control-L. And from here, what we can do is we can go to the help screen. The help screen will have a bunch of different commands. You can do help all. It's going to list a whole mess of stuff. We don't really want to go through all of that, so I hit Control-C to cancel out of that. I'm going to clear the screen again. What we're going to want to do is load a file. And if you're interested in learning about more, typically you can write something like help file, and it'll give you some more information about that particular command. But we're just going to do some very basic commands. So we'll clear the screen. We're going to load our a.out file into GDB by typing in file and /a.out, enter. And we'll see it says reading symbols, and then tell us that it's done. We can go ahead and actually just run the program by typing run. And it does exactly what we did on our command line, and it says it dumps the output, and then it tells us that the process exited normally. So let's use some other features of GDB. So what we can do is we can put something called a breakpoint in, and a breakpoint basically tells us, like, halt this program at a particular function, a line in the program, whatever you'd like. So we can say break, and we can pass in the function name main. It tells us that it place a breakpoint on line 5 of our program. So looking back on our program, we can see line 5 is this line right here. So if we go ahead and clear the screen and type run, we can see that it says that the program was halted at line 5. So line 5, which is exactly what's printed out here, is what our program has halted at. So another way to display lines of text in GDB, we can clear this, is typing L, enter, and it will just give us a list of the general code that is executing, like, that we're around. So if we want to continue, we can clear the screen. We can type the word step. So step just now went from line 5 to line 6, and we're just stepping through the code now. So if we want to step into the next line, we can type step again. You can also evaluate values. So by typing, I can type something like print, and then I can give it a variable name like x, and x is 5. So if I did the same thing for y at this current point, it's going to tell me y is equal to 0. And the reason why y is equal to 0 is because we have not executed this line yet. It's halted here. But after we step over this line, and then I hit the up arrow key twice, and now print y, it will be 10. Now you may be wondering why these $signs are here with these numerical values and then printing out on the other side of the equal sign. That's because when you run a print command, it's actually assigning like another local variable to GDB that's easy for you to use. So you could do something like $1, you could type in print $1 and it would print out the same value, but you can see you can end up in this weird loop where it's reassigning that value to another temporary variable. So that is the power of debugging, and this was just a very brief introduction on how to set things up. You can also do different breakpoints. So if we want to do help break, this will tell us different ways to set breakpoints. So you can read about it, but the more programs that we create and the more that we need to debug things, this is what we'll be doing. We'll be writing programs, running those programs, debugging them, stepping through them to get a better understanding of what's going on. Another quick tip that I'd like to mention in GDB is the ability to print out variables in different formats. Now, what we're going to do in this quick portion is we're going to just execute our GDB instance again against the a.out file that we created before. So we're going to go ahead and launch GDB. We're going to clear our screen. We're going to tell the file that we want to load, which is our a.out file, and we're going to place a breakpoint on our main function. Now what we're going to do is we're going to run the program. It's going to hit the breakpoint on line 5, like it said it's set. We're going to clear our screen again. We're going to step, and then we're going to step again. And now it's telling us it's on line 8, and we do not want to run anything else at this particular point. We're going to clear our screen, and now we're just going to examine different ways to print out things or examine particular values. Now, the one thing that I'd like to show you is the ability to print out variables in binary formats. So that's going to be the X command. So if we go ahead and type help X, it will tell us this evaluates a particular memory address. So we can clear this screen and type in X and a modifier. We didn't find out what modifiers there were. So let's go ahead and go back to the help screen, and it will tell us here, if you read format letters include all of this stuff, and we'll see that there should be one in here, T. There it is. T is what we want. So we'll go ahead and clear the screen. We'll type X/T, and for this particular case, since it takes an address, the address of, we have not learned this yet, but the address of operator is the ampersand sign, and we're going to say X. Now we can hit enter, and you can see that this is the binary format of our value X. And if we print X, X is equal to 5. So this number here represents, this binary number represents the value 5. So we can actually use print as well to print our binary. We can say P or long print /T X. And you can see that it's the same as this first 3 bits here. It just does not print the remaining bits inside of this 4-byte collection. So this is basically all I wanted to show you. P is actually a shortcut for print, so you could use the same thing. You could do P/T X, and it will print out the same value as above. And you can do the same thing for Y. Just to show you, we'll examine Y. And remember, the address of is the ampersand sign, Y. And this is actually the address of that memory location. So we'll get into addresses and all of those things in a little bit later when we start talking about pointers and how those things work. So this is basically the only commands that I wanted to show you at this point. The examining binary at this particular point in the course is probably not particularly useful to you, but it's good to at least be exposed to it.